Hello guys, in this video we are going to discuss the solution of the problem longest valid parenthesis. So let us look at the problem statement. The problem statement says given a string str consisting of opening and closing parenthesis, find the length of longest valid parenthesis substring. A parenthesis string is valid if for every opening parenthesis there is a closing parenthesis. Opening parenthesis must be closed in the correct order. So for instance, if this is the string which is given to us, the longest valid parenthesis substring is this string and the length of this substring is 2. That is why we are returning 2. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is maintain a stack which stores invalid indices of the string. And once we have these invalid indices, all we have to do is use these indices to compute maximum length substring. So let us understand this with the help of an example. So let us say this is the string which is given to us, and let us write down the indexes. So this is 0, 1, 2 and so on. And then let's have a stack. And onto this stack what we are going to do is we are going to maintain the list of invalid indexes. Now let us see how we will be able to maintain the list of invalid indexes onto the stack. So to begin with, 0th index is a closing bracket, and since there isn't any opening bracket, because of which this is an invalid index and we are going to push it onto our stack. Now 1 is an opening bracket, we are going to push it onto our stack. And as soon as we obtain a closing bracket, so 2 is our closing bracket. Since we have obtained a closing bracket, we are going to pop an element from the stack. Similarly, 3 is an opening bracket, so we are going to push it onto the stack. And 4 is a closing bracket, so we are going to pop it from the stack. Now, 5 is an opening bracket, so we are going to push it onto the stack. And as you can see, towards the end of this operation, what we have obtained is a stack which contains indexes 0 and 5. And these are the indexes which are invalid. 0 and 5 are invalid indexes. Now what it simply means is the string, the 0th and 5th character contains an invalid string, which simply means that this is a valid string. And all we have to do is we have to compute the length of this valid string. And in this case, the length of the valid string is 4, and which is what we are going to return. So that's the general idea behind solving this problem, folks. Now let us work with an example extensively in order to understand the entire concept, and then we will discuss it pseudocode. So let's take the same string which we have, and let's take a stack. And let's start with I equals to 0. Now since 0th index is an invalid index, because of which we are going to push it onto our stack, and then we are going to move our pointer to the first position. Now since 1 is an opening bracket, we are going to push it onto our stack, and then we will move to the next position. So 2 and 2 is a closing bracket. As soon as we obtain 2, we are going to pop an element from the stack. So this 1 will be popped out, and once we pop an element from the stack, then we are going to compute the current maximum length. And the current max length will be given by the current index I minus top of the stack. So in this case, I is equals to 2 and top of the stack is 0. So 2 minus 0 equals to 2, and that is the current maximum length. And as you can see, this is what this gives us. The current maximum length is 2. Now moving forward, we are going to move to the third position, and since third position is an opening bracket, we are going to push it onto our stack. And then we are going to move to the next position, which is fourth position. Again, fourth position is a closing bracket, because of which we are going to pop an element from the stack. So 3 will be popped out. And again, since this is a closing bracket, we are going to compute our current maximum length. And the current maximum length will be given by, again, I minus stack dot top. I over here is 4 and stack top is 0, because of which we are going to have 4 over here. And the current maximum length will be 4. Now we will move to the next element, which is 5, and since 5 is an opening bracket, we are going to push it onto our stack. And towards the end of the loop, we have computed our maximum length substring, and that is what we are going to return. There is one more concept which we need to understand, folks, so let us discuss that. So let us say in this case the string is something like this, and the indexes are 0, 1, 2 and 3, and we have our stack. Now I equals to 0, and 0 is an opening bracket. So what we are going to do is we are going to push 0 onto the stack. Then 1 is a closing bracket, and we are going to pop an element from the stack. So this 0 will be popped out, and then we have to compute our current max length. And as usual, the current max length will be given by I minus top of stack. But in this case, there isn't exist any top. So in order to counter this, what we do is we maintain a stack, and to begin with, we are going to push a -1 onto the stack. And then we are going to iterate from I equals to 0. Now I is equals to 0. Since 0 is the opening bracket, so we are going to push it onto the stack. Then comes 1, and since 1 is a closing bracket, we are going to pop an element from the stack, and then we have to compute our current max length. And current max length will be given by I minus stack top. In this case, I is equals to 1 and top of stack is -1, which will be equals to +1 over here, and that will give us 2. And in this way, we will be able to solve this problem. So to put everything together, what we are going to do is we are going to take a stack, and we are going to push -1 onto the stack. And then we are going to proceed with the logic which we have discussed. So that's the whole idea behind solving this problem, folks. Now let us discuss the pseudocode of this problem. So let's say we want to find out max length, and a string is given to us. So for this, let's take a stack, and let's push -1 onto the stack. Let's take an answer variable and initialize it with 0. Then we are going to iterate on I in range of len of str. The first thing which we are going to check is if stri equals to an opening bracket. If it is an opening bracket, all we have to do is we have to push an element onto the stack. So let us do stack.append, and let's push I onto the stack. And if this is a closing bracket, we are going to check whether stack is empty. If stack is not empty, then in such case, all we have to do is we have to pop an element from a stack. And after popping an element from the stack, again let us check if stack is not empty. And if stack is not empty, then we are going to compute our answer, which will be equals to max of existing answer, comma, I minus top of stack. And let's say in the case if stack is empty, all we have to do is we have to push an element onto the stack. So stack dot push I. And then towards the end, all we have to do is we need to return answer. So I hope this part is clear, but let me explain these parts as well, why we are doing this. So let's take the same example where str is something like this and stack contains -1. Now the first bracket is a closing bracket. So we want to pop an element from the stack. And as you can see in our pseudocode, we are not comparing whether the element is an opening or closing bracket. We are just checking whether it's not empty, and if it is not empty, we are popping it. So in a sense, the invalid indexes which we are putting onto the stack is also getting popped over here. So this will be popped. But now since we have to maintain the list of invalid indexes onto our stack, so this has to be inserted back into our stack. Because of which this condition. So we will be in the else block. If stack is empty, we are going to push I onto the stack. So this I, which is equals to 0, will be pushed onto the stack. And that is the reason why this condition is there in our pseudocode. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So we have a stack and then the answer, and on stack we are pushing -1. If it is an opening bracket, then we are pushing I onto the stack. Otherwise, we are checking whether the stack is not empty. If stack is not empty, then we are popping an element from the stack. And then we are checking whether stack is empty or not. If stack is not empty, then answer equals to maximum of answer comma I minus stack top of stack. Otherwise, stack dot append I, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Over here we have a stack, then an answer, and initially we are pushing -1 onto the stack. If it is an opening bracket, we are pushing an element onto the stack. Otherwise, we are checking whether the stack is empty. If a stack is not empty, then we are popping an element from the stack. And again, we are checking whether a stack is not empty. If a stack is not empty, we are computing our answer. Otherwise, we are pushing I onto the stack. And towards the end, we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.